Hello, good people. Today I want to show you something to do with Kubernetes and how you can deploy an application in Kubernetes. So basically I have a springboot application that is connecting to a Mysql database, and I have already made a simple app. So I won't be like starting from scratch, but I will just take you through the steps that I've followed to have the application run in the Kubernetes cluster. So maybe before you watch this video, you need to um, familiarize yourself with setting up a Kubernetes locally. You can use Minikube, or you can just in your Docker desktop, you can just enable Kubernetes cluster. Let me show you. So if you come to your Docker desktop, by the way, make sure your Docker desktop is running. So come here and come to Kubernetes. Make sure it is enabled here. Otherwise, it will not work. So we come back to the application, and we see how it's first of all developed. It's just a simple Spring Boot application, nothing fancy. So maybe before we start, I'd like to show you the end point, the end goal of how the application is running in the Kubernetes cluster. So first of all, we have ID, name, admission number, age. So this is the database that I've hosted inside the cluster, and I have also the app now that is now exposing that endpoint, and this one is the node endpoint from the cluster now. So that's why that's where the application is being exposed to my local computer. So that's why I'm able to access that, and so yep. So let me show you how that is done. So if just to take you through the application, nothing fancy as I told you before. I just have a simple Spring Boot application. If I can start with the model to show you how it looks like. So I have a student's model, just the ID, name, admission number, and age. Then I have the repository here. As you know, the repositories, that's how they look like. Then I have the service now that is now calling the repository. I inject the service there. I inject the repository there, and then I have my DTO just to format my request. And here I have my controller. I have the controller. This is the get, the one that you are calling. This is actually the method you are calling, and it will get that data from the database. Then this is for posting. I have not yet tested that, but maybe you can test together. Yeah, that is the application part, and then that is the application part. Then I have the Docker file now to create an image of this application. So I start with this part, that is OpenJDK 17. Set up my working directory. Copy the build files, the Gradle build files and the settings. Then run all these commands. This thing I'm doing it twice. I don't. It helps me to build the image faster. I'm new to the whole thing about Docker. I'm just familiarizing myself, but ChatGPT recommended that I build twice. but yeah, I've seen that work. And then here I copy the build. Okay, this part is the one that is building the application, and it will be named students.jar. Then I copy that now from the previous build, because I'm using multi-stage build. So this is the second step to be copied from the previous stage, and then it will be copied to my application. Remember, I set my application here to be my my app. This app, I mean, to be the working directory. So just come to copy from the previous stage. I copy these two, the app that is the working directory, and I name it students.jar. I expose port 8081 from the container, and actually this should be port 80. I don't understand how it's working, by the way, but maybe somebody can tell me. So I expose port 8080. Then basically this is a running command that will be run when the container starts to run. That is the Docker part. And then from the Docker part, now I'll assume the image has been built. Maybe if we can build it together. So basically, for me to build the image, I have a bash file that will build the image from. Let me come to DevOps. I have a bash file here. So I'm telling it to go to the directory where the application is, and I tell it to build the image. So docker build, tag it as this name, and the version, to pick the version from here, so that if you come if you want to add another version, just call it 2, and it will be picked up at this point. Then I here I just apply this file to the cluster. I'll show you where this file is, and then yeah, basically that's my build process. I can just run that. So if I come here, let me just do the build file, make sure I'm inside the download students DevOps, and then I do .build. Probably might take some time. I hope it does not take too much time, but because I had run this before, I believe most of the stages will be cached. Let's wait for this. As it is building, I can show you now this part where now the Kubernetes part. So I have on this folder, the DevOps folder, I have so many files, but I just want to pay attention to a few of them. So we'll start with the that's finished actually. I'll show you first the Mysql, how to deploy Mysql database into the cluster. So I'll start with the PVC, that is called the persistence volume claim. So basically, like, as you know, containers, they don't have storage, because they are ephemeral, and if the container dies, we don't want to lose our database. So basically, Kubernetes provides another service for you to connect your storage path, or your storage disk to the cluster, because Kubernetes basically does not have you cannot have a database configured inside Mysql, inside the cluster, and it being persistent. It cannot be persistent, because when the container dies, that data will be lost. So persistence volume claim basically helps you to store your data outside the cluster, so that your data, when another pod, okay, when another container starts, it will just pick the data from your external storage. Yeah. So basically this is a persistent volume claim. You just call it, and you just give it a name, MySQL PVC, and you give it the size of the memory that you want to have to allocate, and then yes, from here, now this is the first thing actually that you need to have. And for you now to apply this one, you will come and run kubectl apply -f the MySQL PVC. Yep. Because I had already applied that, that's why it is telling me it's unchanged. And if I come to my terminal and I want to see the PVC, I can run kubectl get PVC. No, okay, this is the PV actually. Let me see the PVC. Yes, I have MySQL PVC here. This is the one that I have created, the one I was describing here. So this is the PVC. I had another one I had created earlier. So then from there we have the deployment now. MySQL deployment. If you have ever worked with Kubernetes, you know how a deployment or the structure of Kubernetes, how the Kubernetes work. Basically, if I was to do a quick illustration of how Kubernetes work. So in Kubernetes, we have something that is called a pod. A pod, this is where, let me just expand this one a little bit. This is where you have a container. Let me draw a container here. Let me put my container there. So this is your container that now holds your application. Is the container, Docker container that holds your that has your application running. Then here we have the pod. Here we have the pod, and the pod is the one that now manages this container. Actually, in Kubernetes, you don't ever interact with the container, you interact with the pod. And for this case, a pod usually has an IP address. Has an IP address here. We can call it 192.168.0.1. That could be the IP address of the pod. And remember, this pod, when this pod dies, this IP dies as well. And that's why now I'll show you how you can mitigate that, and how like Kubernetes mitigates where the cases where this pod dies. Like, how do you know the next IP address? Yeah. So basically that's a pod, and a pod actually runs in a node. A node in this case, if you come from the AWS world, a pod could be an EC2 instance. If you are from DigitalOcean, we could call it a droplet. Yeah, this could be one droplet. And so your pod runs inside the node, right? Inside the node. So if I just expand this node, make it bigger, just bring this one here. So we have this is the node. This is the node here. This is the node, and the node actually as well has an IP address. has an IP address as well. Example, this is the node IP address. You could call it just call it, maybe give it a say 5 and give it a 2. Maybe that's an IP address for the node, or that EC2 that you want to use as your to run your application inside. So there's something else now that is on top of the pod to help the communication. I told you the containers are ephemeral. A pod is as well ephemeral. The Kubernetes can destroy this, or if, for example, if the container dies, the application that is inside the container dies, it will kill the container. The container will cause the pod to die as well, and the whole thing will collapse. And now Kubernetes will replace this pod with another pod, and that IP address will change. That's where the problem comes. How do we know now where our application is now running from which IP address? Now Kubernetes introduces another service that is called service, actually. That's funny. So there's something that is called a service here, and a service is let me call this one service. Service is gets an IP address that does not change, right? So we can rely on this one to communicate with the pod. Yeah, we can rely on the service to communicate with the pod. Now we tell the service, now all the questions we'll be asking, all the requests will be sent to the service, not to the pod, so that the service now will locate the pod wherever it's running from. If it's dead, the service will not reply. But the good thing about the service now is that we have an IP address that does not change. So we can call this one maybe 192.169.0.3. Yep. So this IP address does not change, and services they are there to stay. So every pod is represented by a service in front of it. So now forget about the pods. Now forget about the pods. So let me show you, like let's say, for example, your application, like for this application that I have here, it's running in port it's exposing port 8080, right? So this is the port now inside the container. Now this container exposes port 8080. Right? So let me just bring this one here. Exposes port 8080 to the pod, and now the pod as well now will call this container through this port, right? The pod as well will expose its own port, right? And in most cases you want them to look the same, but they can be different. Yep. So this is the port. Now this pod is exposing to the cluster, or rather to the service that is represented by that represents this port, this pod. So hope I'm not confusing you with ports and pod. These are port, P-O-R-T, and these are pod, P-O-D. Yep. So now the service as well has its own ports. Yep. Where now we will call the service now. So if I was, let me just duplicate this one here. No, let me just duplicate this one here, and this is the port now that now will it can just be 80, right? It can just be port 80. Now where this service will connect to this port here, and then you have another port here now. Now for this, for internal communication, this is internal communication, but now we need the service, right? We need the service now to expose its own port, right? And that port will be, it's called a node port, in case you are now this one will expose the node port here, and they usually have a range like from 3000 to, I can't remember, but I think 33,000 to 32,000 and something. I don't have the right number, but this port needs to be in this range. Yeah, so this is the port now that you'll be able to query and get the application, access the application. So for my case, if you looked at the postman here, it's actually this port here. If I can just copy this one, this is the port that is being exposed for me to access the app. So let me actually name these ones. This one is called a service port, not service port. It's called a target port. Target port. When you're defining your service, it's called a target port. It's called a target port. And this is called a node port. It's called a node port. So node port is where you want to access your application from, or the port that you'll call now from this that is being exposed to the node now, because it's the node. Now the node, this is your EC2 or your DigitalOcean, will call this port to come to the service. The service now will look for the target port. It will get its port 880, and then they'll communicate directly to the container. Yep. So I have my application now here, and first of all, this is MySQL. The MySQL deployment. Something I didn't tell you is, now when you want to create a pod or deploy a container, you just create a deployment. You just create a file that is called a deployment. And then the deployment, under the deployment you can have a service under it, so you can maybe create them as two. There are two of them in the same file, because in most cases you want to have your deployment is always associated with a service, because in your deployment is where you define your container, right? Or rather, not a container. Yeah, we define a container, but you actually define the pod, right? So if you come here, I have my a service that is not a service, the deployment. The kind is deployment. So this is the structure of a Kubernetes deployment. So kind as that you define the version. The kind is called deployment. This has to be like the word literally deployment. Metadata, how do you want to call your deployment? You give it a name, then you give it the specifications. This is where replicas is where you define how many instances of these pod of this application do you want to run. For example, if you say 1, you just get 1 container running. If you say 3, you'll get 3 containers created. So your application will be distributed in 3 containers. Yeah. So assume that maybe you want to build an application that is highly available, and so you want to maybe have like, if one server is down or if one node is down, you want your application, maybe you'll have a load balancer where your application now will be loaded from another node, so that the customers don't experience any downtime. That is, and then you create the match labels. These the match labels is where you now connect your service. I'll show you later. Then you come to the templates, and then you have your labels here again. So here is now you define your containers. How do you want your containers to run? So the name of the container will be called MySQL, and it will fetch the detail, it will use this image from Docker Hub. So basically, when you start this container, it will start this pod, it will download this image from Docker Hub and start that container from there. So the MySQL image has some environment variables. So these are the environment variables that you pass to it. Actually, you could put these in something that is called Kubernetes secrets, so that you don't expose them here. Yeah, but you're just keeping this simple. And then inside the port now, you want to, if inside the container, you want to open port 3306. And then here you have your, how do you want your data to be persisted? Yep. So you mount a volume. Yep. You mount this volume, you give it a name. Then you give it, where does it get the claim from? Where does it get the claim from? So you'll pick this name here is equivalent of the PVC that we created, that is created here. So this is the claim. This is where they connect. Like you're telling it, your storage, basically your container is asking for, when you connect this one, it will claim a storage of 1 GB from your node, yeah, or from wherever you have defined it. Yeah, it can be external. Actually, you can connect an external drive here through the volumes. Yeah, so basically that is the MySQL deployment. Replicas, I told you want to have 3 instances, but for this case, just let me just keep it at 1. Then now we have the service here. The service, as I told you, is now the one that is that communicates to the pod. In case this pod dies, now the service remains, and it will look for the container, the pod, wherever it's running from. So this kind of service, you give it a name, and then you make it a node port. Yeah, the type is node port. There are different types. We have node ports, we have a load balancer, and we have a cluster IP. But for this case, we just keep it node port for you to be able to access it externally. So then we have a selector. This selector should match the name of the name of the label that is defined here. Match labels. These ones should match. Yeah. So that now you can associate this service to this pod, because definitely a deployment will create you a pod. So you can assume this is to be now a pod, and now you need to match these labels here. Needs to match the labels here. Okay, then you come to the ports. Inside but I have not defined any ports here. Yeah, but you give it the name. Okay, name of MySQL. Yes, the port here is now this port that will connect internally to the port. You see, the port here is the container here is exporting is exposing port 3306, and that's by default in the inside the image. And then the target port is where now this service will expose the pod from. Hope I'm not confusing you. Yeah, but in case you have any question, you can always ask. So okay, basically that is the service and the deployment for the MySQL. Yeah, and then how you do it now, you come and apply now this file. If you want to apply this file MySQL deployment, I don't want to do that because I already done that and I have one running, and I don't want to mess up with the database that is inside there. So once you run that, now if you come to now your cluster kubectl ctl and want to get what, get all, I want to show you. Let's start with they are divided into categories. We have the category for pods. These are the pods, and then we have the other category for the services, for the services, and you have other category for deployments. And then these are called the replica sets. Replica sets is basically the number of instances that you want to have for any given container. So if I come and so basically a deployment creates a pod. Yeah, a deployment creates a pod, and because all the pods are running inside an enclosed class, a network, yeah, they are not accessible to us, or they are not accessible to the other maybe the other applications. Now, until you bring up your services. Your services, I told you, are the ones that will expose the pod from the network, yeah, to be accessible through by other applications. So for example, now I have a pod that is called this is called the MySQL pod, and it's running. Yep. The MySQL pod has a service here. Yeah, has a service, and internally the pod the what this service is let me start with the node port. This is the port where we will be able to connect the service. This is where we will be able to connect the service, or rather, if you want to access the database, this is the port. The way we write, for example, let me just show you. If I come to my IDE here, I want to see the properties of this one. Yeah, this one. You see, now on my local host, I can access that service through this port, because that is the port that has been exposed here. Yep. So maybe if I just test the connection succeeded. Yep. And now I have my database that is running now inside that MySQL container. Yeah, I have some dummy data. So that is now but internally now this service is connecting to the pod through this port, if I'm not wrong. Yeah, I told you I'm not an expert. I'm as well practicing. So this is the port now where this service will connect to this pod here. Yep. And by the way, if you want to see the details of a pod, you can just come here, say kubectl describe this pod. I mean, I keep on confusing the two terms. Yeah, so as you can see, this is the port inside the pod that is now connecting the service. Now this is the port that is being exposed for the that is exposed here. If I can, yeah, exposed here, so that now the container, the service and the pod can communicate. Okay, now let's go back to this get all. Okay, so now that's my MySQL what service and the deployment of the container. So you can always access the data now from externally. And now for you to then when you come now to your application, let me close these ones, the Docker file, let me collapse everything. Then we come to the application now. So for your application to connect now to the database, you need to say we come to src main application. Now at this point, now you want to, instead of now writing localhost, if I was running this application locally, I would use localhost. Yeah, localhost. But now, because now this application is going to run inside the cluster at localhost, there's nothing like localhost in the cluster. You need to communicate to the service. You need to call the service. So that's why here I put MySQL service, and now it will know how to resolve this. MySQL service, it will automatically know how to resolve this and get the IP address. So basically, you don't need to know the IP address of the service. You just give it a name, and now automatically that will be solved, and to communicate to that port and get to connect to that database. This is my username, my simple password, and that's how you connect now the two of them. Now you connect your application to the database running inside the cluster, and then what else have I not shown you? Now let's go now to how we deploy the application. Now I have this deployment for the application. As I told you before, we have a deployment students app. You can increase these replicas to 2, so you'll have 2 containers, or maybe you can have 3. You'll have 3 instances of the pods. So if we come here, we'll have 3 instances of this app here. Yeah, and I think Kubernetes offers the a load balancer. I'll confirm that, so that now your containers request will be distributed. Maybe you see that round robin something, like when this container gets a request, the other request goes to the other container, the other request goes to the other container. Yeah, so all your requests are distributed. So you'll have 3 containers, and then here's your match labels, which should come to be the same as in your services. So this is let's come to the container part. Container part, this is the name of the container, and then I'm building my image. I built my image as you saw in the Docker file here. I'm building my image. After building my image, and this is the version that I want to use. So if I go to my Docker Hub, I have this image already, and then inside the container, I'm exposing port 880. Yep, because actually this is what is being exposed by inside the Docker file. And then I have my environment variables. I have the host, port, DB, school, user, password, and then I mount the volume. But okay, on the volume, my PVC. Then I have the service now that it will sit in front of this pod. Then I make sure that I'm using node port so that I can be able to expose. The service. Then this is the port Then this is the node target port. Target port is, this can be different, but this one has to match with this one here, because you cannot expose port 881 and then here you want to, like, basically this is the port, this port target port is whatever you have defined here. Like, you are telling this service which port do you target, the one that is running on port 880. I mean, you have defined your service and you have told it this is your what, this is your pod. Okay, that's my pod. Which port is it running on? Which port do I target? You tell it. Okay, yeah, look, let me look for you. Port 880, so add port 880. Then, as usual, you come and hit this one. So apply students deployment. Let me hit that one. And then the only thing that has been changed in that file is the replicas. Then yeah, so your application now will be, if you come out to the cluster here, you will see your application has scaled up the containers. If you can look at these pods, there are 3 now, because we defined three replicas. Yep. Then we have one service for the app. We have one service for the app that is now, we can access our app through this port, node port, and now internally it will communicate to the either of these containers. Service will know which container to call. Yep, it will call these containers. These containers, they are exposing port 8080, right? What else have I not told you? So we have the service, we have the pods, and inside the pods we have containers running now. And maybe if you can check what's inside this container. But now our application is distributed equally. We have a copy of our application here. We have a copy of our application here. We have a copy of our application here. And if now, let me just show you. If you can go inside the pod, we can just do like kubectl minus it interactively. That one, that's the pod, that's the name of the pod. And then we want to what? Let me just remember that command. History. Do grep. I want to search for bash. Yep. So bin bash. So it's something like you want to interactively to go inside the pod. Let me show you. So I get the container, the pods again. But now this time I want to go inside one of these pods here, and we see how it looks like. Come on. So okay, so as you can see now, this part has changed. Now I'm inside the pod, and I'm actually inside the app folder, which I defined in the Docker file. I told Dockerfile to create this folder for me. So if I go and do lsla, I have the students.jar. Yep, this is the students.jar, and this is now this is where application is. Yep, and if I go back again, I can have lsla, I have a simple kind of a Linux file system, very simple. Basically does not contain all the commands because it's a very lightweight Linux file system, but you have like most of the things that you need. So as you can see, I have my app here. This is where now the application is running from. Okay, so that's my application where it's running from. And if you do the same, let me just exit one. And if you do the same for this one now, you'll see that you have the same. This is another pod now, or rather another container. So ls/la, you have your application again here. Yep. So as I told you, the replica set duplicates your application into 3 different pods. And now in the case of EC2, you'll have to deploy this one in a different in one EC2 instance, or in one droplet. You'll want to deploy this one in another droplet. You'll want to deploy this one in another instance, or that is EC2 instance, so that you have your application distributed, like distributing your risk. Then this service here will know how to reach all these guys. Yeah, this service will know how to reach those guys. So like your concerns reach here, you just need to call me and I will call for you any of the pods that in your application. I know where it runs. Yeah. In most cases, actually, you don't know where. Like, for example, you deploy a pod, or you deploy an app inside the cluster, and Kubernetes decides where to. I think that they have that logic. It has that logic to randomly choose which node is healthy, which node matches the requirement. For example, you have a node that is maybe that has a very low usage, maybe in terms of resources. So maybe the RAM, that Kubernetes will decide for you where to deploy the pods. Yeah, and it will manage them. And if one pod dies, Kubernetes will automatically create another pod because of the replica set that you said that we defined here. So this replica set, Kubernetes will always make sure that you have 3 pods running at any given time. You have 3 applications running, and now they will be distributed into 3 different servers. Now this is inside the pod. Exit that one. What have I not showed you? These are the replica sets. And yep. Now let's now access our application. Yep. Our application now, we have this service now. We have this service, right? And this service is exposing to us this port 31664. Yep. So if we go to localhost 31664, and then our application is, if I look at the controller here, let me just go to the container, the controllers, and I had defined that if you go to API/students, it will call this method. So if we just do like curl localhost port, the node port, then my application, I know it's students. If I call that one, you see I get my data. Yeah. Now that is how you configure your application to run inside the container Okay, yeah, definitely run inside the container, and eventually to run inside the Kubernetes cluster. And you all know the advantages of Kubernetes. They have a lot of advantages. I don't want to dwell on that, but the most important part, as I was doing this, I was wondering, where do I connect the database now? And maybe to do a recap for the same, you do it inside you make sure that you come to resources. You make sure that you are calling the service, and you know the port. Yep, I think that's all. And you can also now access this application through Postman. Postman, where now make sure you have your what? You have your Docker desktop running, and actually your containers, they are running in one of these Kubernetes. What, like you can see, this is my MySQL deployment. This is the app. This is how the app is, where the app is running. And I have another replica, I think. Yeah, that's how these things work. This is now the container, I think. Now this is the pod. And if I can see the file system, actually, as I was showing you. Okay. Yep. So you need to have your Docker desktop running, or yeah, that for that to work. So basically, that's it in a nutshell. If you have any question, I'm not an expert in this, and if you see if you see that I make, if you have seen me making any mistake, please bear with me. I'm also learning. Yeah, but basically, if this video helps you to understand, well and good. I'm happy to help. Maybe whenever you have a question, you can always reach me, and I'll make sure that I put this code in a GitHub that is publicly accessible, so that maybe when you want to copy the same, or you want to learn, you can use this one to, yeah, to be able to run your containers inside the cluster. Thank you guys. Bye.